we want to graph a parabola. Notice our base graph is y equals x squared. But that negative out in front tells us it's going to be upside down. That's another way of saying it's going to be reflected across the x-axis. And you can see that the minus 1 in there is going to refer to moving the graph right 1. And the minus 2 at the right there is going to refer to down 2. So we typically have a parabola going through the origin, and we've got these other key points at 1, 1 and negative 1, 1, and over 2, up 4, and to the left 2 and up 4. So those are the peg points that I have memorized for your standard parabola. Now, instead of having it centered or with a vertex at the origin, we're going to go right 1 and down 2. And this is going to go down 1 over 1 and down 4 over 2 to the left and right. And we're going to have these points to draw out the curve. And you can verify this if you want. You could take this point, for example, that was at 1, negative 2, substitute it up into the original function, and verify that it is indeed on the graph. Okay, let's look at this next function. Notice how inside the radical we have two minus signs. I'm going to rewrite this as negative and factor out the negative in front of this x plus 4. That's how we want to look at this. Now that x plus 4 actually tells us that we're going to be shifting this graph 4 units to the right. But that negative inside, in front of that parentheses, basically says we're going to reflect this across the y-axis. Now, which one gets done first? The answer is, as we saw on just the previous page here, we're going to be doing the reflection first. Let's graph our basic square root graph. That's going to be these 4 points, 0, 0, 1, 1, 4, 2, and I'm going to dot that in very lightly there. When we reflect this across the y-axis, we're now going to have these points on the left-hand side, and I'm going to draw this as a solid curve. There's the reflection across the y-axis. Now we want to move this 4 units to the, I said right. I was falling into that trap there. That plus 4 actually means 4 to the left. And sometimes it's a good idea to make a mistake in front of a class here because it helps you to memorize it all the better. So I'm going to have these points here instead, and then we've got this graph. Now let's check this point negative 4, 0. Let's verify that it works in the equation. When you substitute this in, you get negative of a negative 4, which is 4. Minus 4 is 0, which square roots to 0, and that point, yes, is on our graph. Use transformations on this graph, on the graph of y equals f of x, that would produce this graph. In other words, what is this equation? We obviously know that it is in the absolute value family. So its base graph is y equals the absolute value of x. Now its vertex, instead of being at the origin, is down here at negative 3, negative 4. So we've really gone left 3 and down 4. Let me write that down. Left 3, down 4. Okay, let's rewrite this function. It's going to be f of x equals left 3. That's going to affect the x, and instead of going x minus 3, it's going to be x plus 3. And the down 4 will be a minus 4 off to the right there. For this next problem, we notice that its base graph before shifting would be y equals the square root of x. Now it looks like it's been shifted down 2, and I notice an up 1 over 1 and an over 2 up over 4 up 2. So it looks like it hasn't changed its curvature any. So the down 2 is the only thing that we're going to deal with here, and that means just putting a minus 2 at the end. F of x is equal to the square root of x minus 2. Make sure you don't put that minus 2 inside the square root.